Okay, so we're getting quite a bit closer here on the Kyosho Inferno 10E electric conversion. Since the last video, I made some modifications to the upper deck. I finalized the battery mounting option that I'm going to use, and I also set up the motor mount. So I'm going to go over these things here. So for the batteries, I was thinking about, maybe using a shorty or an ultra shorty or a saddle pack. I ultimately decided to use the saddle pack. Part of the reason was because I already have saddle packs, and I didn't see any point in buying a new type of battery like an ultra shorty just for this car. So if I could make it work with saddles, that would be preferable. Also, a saddle pack would probably give me the best, most even weight distribution left to right, because if I ran some kind of a shorty or ultra shorty pack over here, I'd have battery weight on this side and motor weight on this side, and the only thing on this side would be like the speed control, the receiver, the servo, which are much lighter. So that would have meant, having to run the shorty pack on this side, and then putting electronics, here and here running over the spur gear, and I'm just not sure I wanted to do that. So I had to make the saddles work. So in order to do this, I actually had to cut away some material from the upper deck here. So the original upper deck has mounting points here for two servos for throttle and brake for the original Nitro setup. And you don't need those anymore, and you can cut those out and still maintain structural integrity of the upper deck while giving you more space here to access this side of the chassis to, put a saddle in and take it out. So that's what I did. The way I cut it out, I did also cut around a hole that was about here that mounted down to another post that goes into the chassis right here. There's a hole here that a support post goes onto that supports this part of the upper deck. So you lose that part, but you gain a lot of space, a lot of access room, which is very important. And then these are B44.2 battery cups for the saddle packs. I had to set them up a little differently left and right. So you notice on this side, the actual sort of screw portion is toward the back. And that's because if I put it on this side, it would run into the upper deck. So the only clearance I have is doing it on the back here. And then on this side, the screw portion is toward the front, because if I ran it toward the back, it could run into the sway bar turnbuckle here. Okay, so it's kind of like, opposite on either side. Another thing I did was to expand the hole on this part of the upper deck. Originally the hole is about that, and I basically just pushed it out with some dremeling, so that way when I wire up the saddle pack, I have access to that plug on this saddle, and then I can just loop this over the chassis and over the center drive shaft to this side to plug into here, and then I have my positive and negative leads here that can go to the speed control. So that's for the battery, pretty straightforward. For the motor, the actual motor mount here is part number TR404B. This is the motor mount for the DBX VE 2.0. And it's a relatively inexpensive motor mount. And basically there are 3 mounting holes for that mount. There's 1, 2, and then on the other side here, a little hard to see, you can see where that nut is, it's 3. And the way it goes is, you thread a screw in from underneath, and then you put a lock nut into a little slot here, and that just tightens it down. And these slots exist on all 3 mounting points. So what I had to do was mount the motor onto the motor mount, and then put a pinion gear on this just for spacing, and basically move this around until I got it to mesh, reasonably with the spur gear, and then mark that position on the chassis, and then take everything off, put the motor mount back on to where the marked position was, and then dot out where those holes were, so then I have a reference for drilling those 3 holes through the chassis, countersink them on the back side, and then I have my motor mount. This is a bit of a pain to get the gear mesh right, so I did a little bit of math today to figure out what size pinion gear I would need to get roughly the same final drive ratio on this as I do on my Yokomo YZ1093 Works, because that car has a 13.5 motor, and the way I have it geared and timed, it works really nicely. So basically what it means is I would need a 15-tooth pinion gear here. This is, I think these are Mod 1 pinions. And so in order to make that work, I test fitted this with a 12-tooth pinion, knowing that I may have to go bigger. So I put the 15-tooth on, and then you loosen these 3 screws on the underside, and you just slide this whole motor mount out this way, and then you put the bigger pinion on, remesh it, and then tighten these down. But because you have 3 tightening points here on the bottom, as you tighten down one of these screws, it's going to move the mount around a little bit. So it does take quite a bit of trial and error and iteration to be able to tighten down each of these 3 screws in the right sequence, so that as you tighten them down, it doesn't distort the position you want it to set it up in and end up screwing up your gear mesh. Okay, and you set the gear mesh as you're looking down this way through the bottom of the chassis, through this hole here. So this hole is actually a very important hole. So you don't want to cover this up in order to, keep dirt from getting. I mean, you can put Lexan there or something, but make sure you keep it clear, so that way when you have to set the gear mesh, you can look through that hole. Okay. So that's the motor mount. Real pain in the butt. The other thing is, if you're going to say change the motor, that's going to be a lot of surgery, because the screws that screw into the motor through the mount, there's one on this side here on the top, and then the one on the bottom is back here. And even if I take this battery out, there's no way that I could reach that bottom screw with a nut driver unless I have a hex driver with a rounded hex head, which for these 3mm screws I don't have. So that would mean that I have to take this entire motor mount off. Okay, sounds fair enough, but then if I take this motor mount off, when I put it back on, I have to put these nuts on and then thread the screws through, which is fine for these 2, but the third one over here, which is kind of deep, you can get to it right now because there's no steering servo in here, but once the servo's in here, I won't really be able to reach this nut. So that means I'd have to unmount the steering servo, maybe even take off the upper deck if I have to, just have a bit more space to work in here, and then take this off. So it's more surgery than just removing the 2 screws you would normally use to mount the motor onto the motor mount. There are other parts you have to remove to take this out. And that kind of is a sort of a consistent theme with the rest of this car. Even though as it's set up right now, it's starting to look more and more like a modern Kyosho laser. Adjusting things like the gear diffs, I did set these up so they'd be sealed gear diffs that you could adjust with different diff oils, but getting to those diffs is a lot of surgery. I got to take the upper deck off, I got to take, the shock tower off, I have to, take these turnbuckles off, and then I have to take the left and right halves apart to get to the diff. So there's a lot of screws, unlike a more modern 4-wheel drive buggy where it's maybe 4 screws on the front, take them out, gear diff comes right out. So certain kinds of adjustments like that in this car are harder to make, or they take more time, even though the car itself is starting to look more like a modern buggy than a vintage buggy. So just bear that in mind. So the next step for me now will be to mount the steering servo, and for that I have a Turnigy TSD99X. It's a shortened length servo. I forget what they call these. It's a low profile servo. My vocabulary is bad so late at night. So low profile servo, so that way the back end of the servo doesn't extend too far out of the edge of the chassis. Now, it turns out that with the Inferno 10, there were 2 generations of Inferno 10. The first generation of Inferno 10 had a hole here where the servo mounted down like this onto the upper deck, and then you set up your servo horn and everything to drive the steering rack. On the second generation Inferno 10, which is what this appears to be, you just have this slotted hole here and this hole here, and you have little posts that you mount the servo not down, but in this way. Again, mounted to the upper deck. Okay, but I want to be able to remove the upper deck without having to move the servo around. So I'm going to have to drill another 2 holes on the chassis here and put mounting posts on the chassis so I can just mount the servo directly on the chassis. So I have to set that up, which means taking some of this apart. And then once that's ready, okay, so let's just imagine that goes in there somehow. Then we have to figure out where the speed control goes and where the receiver goes. There's not enough room over here for the speed control, or certainly the types of receivers I use. And there's not enough room over here because there's this big opening here that everything would fall through, and there's all these gears that are moving that, you know, you don't want to get wires in the way there. So really that means using the upper deck. So I have, you know, this space here on the upper deck and this space back here. And if you consider a typical body profile, like this is a Kyosho Laser ZXR body, and I did cut the back part of the body further in order to accommodate this sway bar. I talked about that in the previous video. The profile of the body is much lower towards the front. So if you're going to put any type of electronics on the upper deck toward the front, it would you'd want it to be maybe a receiver. Receivers are lower profile than speed controls, and they have fewer wires. So maybe the receiver is going to go up here, and then maybe back here, I can find a way to mount the speed control either on just this surface area right here, which hopefully is enough. I don't know if it will be, or maybe I put an extra plate on here to extend the surface area out toward this side to buy me some area to mount the speed control. And then I just route the motor wires down this way, and then the battery wires go here, and then the wire to the receiver maybe goes down this way to the receiver. So that's kind of what I'm thinking. Receiver up here, speed control back here, transponder can go up here or something, and that's probably how the electronics will mount. And then once all that test fitting is done, I got to tear the whole thing down and clean up this lower deck. As you can see from this video and some of the other videos, it was a blue anodized chassis, and you know, through use from the previous owner, it got kind of scratched up or kind of sandblasted or something. So I want to just strip all the anodizing off, and you know, either hit it with a Scotch-Brite pad like what I did for the upper deck here, just to give it more of a brushed aluminum look, or maybe I might want to paint it a different color, in which case I have to go to Home Depot and pick up some enamel paints. So I haven't decided yet whether I want to paint the upper and lower deck or just give it the brushed look. But then once that's done, it's more or less set to go. So far so good. It's starting to look, you know, more complete. And I want to get the the electronics all finished up and the chassis all cleaned up. Then I guess I'll make another video. So until then, thanks for watching.